Is one of the 7 planets NASA discovered that are the size of Earth habitable? Earthly exploration of distant galaxies' planets is always predicted on one core question: are the alien celestial bodies potentially habitable? Even though researchers have identified over 4,900 exoplanets in over 3,600 systems, there is still no evidence of a genuine Earth twin. This adds to the excitement of the news that made headlines a few years ago. NASA personnel were able to add 7 Earth-sized exoplanets to the star charts. Welcome back to our channel. Today we will be talking about the 7 Earth-sized planets discovered by NASA. We will also discuss if any of these planets are habitable and if survival is possible there. If you haven't subscribed to our channel yet, you can do so by clicking here. Are you interested in learning more about the universe's astounding discoveries regularly? Don't forget to hit the bell icon so you can stay up to date with our latest content. Let's begin. 7 weird worlds. About 5 years ago, on February 22, 2017, NASA reported another exciting discovery amid the vast expanses of the cosmos. According to the news, the famous space agency's team had successfully tracked the interesting planetary system around the red dwarf star TRAPPIST-1. The fact that the 7 celestial bodies detected were exoplanets the size of Earth made this exciting finding unique. During this galaxy discovery, the scientists questioned themselves, as is so frequently the case: is one of these alien planets possibly habitable? Furthermore, might life have already begun there? We still don't know for sure 5 years after the initial finding. This is not to say that our understanding of extrasolar planets has not improved in recent years. We now know that the objects 41 light-years distant are rocky planets, potentially twice the age of our solar system. Experts are currently anxiously anticipating the impending James Webb Telescope study mission to address the outstanding questions regarding this interesting planetary system. Webb will be larger and more powerful than any previous space telescope, with the primary goal of studying the atmospheres of exoplanets. The examination of the 4th innermost planet, known scientifically as TRAPPIST-1, has piqued the interest of astronomers. The backdrop is E. The celestial body is precisely placed in the center of the area known as the habitable zone in the realm of astronomical study. The habitable zone is the distance between a planet and its central star that allows water to exist in a continuously liquid state. We all know that liquid water is essential for the genesis of Earth-like life. The planets in the TRAPPIST-1 system circle significantly closer to their central host star than the constellations in our solar system. In reality, the orbits of the exoplanets all fall inside the orbit of Mercury, our innermost planet. This, however, does not diminish the possibility of celestial bodies becoming habitable. The equivalent red dwarf star is not just far colder than our Sun, but also much smaller. The physical location of a planet inside the habitable zone is an essential hint in the hunt for extraterrestrial life-friendly celestial bodies. However, it is not the only factor that must be considered in this respect. The primary guideline is that a planet must have an excellent atmosphere to be categorized as possibly habitable. Although the Hubble Space Telescope was used to analyze the atmospheres of the TRAPPIST-1 planets properly, the data may have revealed some fascinating discoveries. For example, Hubble verified that at least 3 of the extrasolar planets' representatives do not have the inflated atmospheres characteristics of massive hydrogen accumulations of gas giants such as Uranus and Neptune, which specialists widely accepted. Indeed, planets with such natural characteristics are incompatible with supporting life. The information gathered so far suggests another equally attractive alternative. According to this, the atmosphere might potentially support the presence of constantly liquid water on the surface. However, astronomers are the most hopeful that the planned deployment of the James Webb Space Telescope will detect carbon dioxide. Its existence is also required for life on Earth. If CO2 were entirely removed from the atmosphere, our planet would be a lifeless celestial body. However, the sizes of the discovered heavenly bodies may also give vital information about their potential habitability. As previously stated, the size of exoplanets is similar to those of our world. This refers to both the diameter and mass of the different extrasolar planets. The researchers were able to calculate the planet masses due to the spatial constellation of the celestial bodies. With the use of recorded gravitational effects, astronomers could establish the likely groups of the different planets as they migrated closer together around their parent star. Finally, utilizing the information about mass and radius, the specialists discovered the density of the planets. These characteristics implied that they are solid rock planets. Experts employed computer-based models to study the likely genesis and development of the planet's atmospheres. Researchers may consider a broad range of hypothetical parameters and improve the associated computer models in both directions. Whether the TRAPPIST-1 system's members are hostile, rocky deserts, or livable planets, The research of the exoplanet Kepler-16b sits on Tatooine planet, where a popular science fiction saga meets the reality of the galaxy. This celestial body is 245 light-years distant from us, much like Luke Skywalker's mythical home world. It orbits not one, but 2 stars. Researchers have now achieved a new milestone in their extensive examination. For the first time, astronomers used an Earth-based telescope to identify the double-star planet. If we set the clock back a few decades, we arrive at a period when the existence of such double-star planets was still highly debated. Planets often develop in the protoplanetary disk of their host star. When 2 or more of these gleaming luminous celestial bodies conceal substantial gravitational perturbations, gas and dust accretion occurs. At least, this is the gist of the persistent spaghetti theory, which was finally debunked by the universe itself. Around 11 years ago, scientists identified an exoplanet Kepler-16b, which circles 2 host stars for the first time. The number of circumbinary planets has increased dramatically since then. Some of these celestial bodies discovered orbit 3 parent stars. The transit technique has been used to identify the double-star planets as it has for most other exoplanets. The actual planet is not directly detected in this detection technique. Instead, the celestial body's brightness fluctuations as it circles its parent star are recorded. However, our earthly perspective on this cosmic quest for remnants is also a constraint. As a result, we can only perceive variations in the host star's brightness when the planets pass directly in front of it as viewed from Earth. The so-called radial velocity approach is more precise. This technique is based on the assumption that planets and stars have the exact center of mass. Consequently, giant exoplanets have a discernible impact on the velocity of their parent stars. Using this approach, scientists can not only calculate the mass of an extrasolar celestial body, but also avoid relying on the apparent direction of the planet's orbit. Researchers could not examine a double-star planet using the radial velocity approach for a long time. They have now accomplished this in the instance of Kepler-16b. This intrusion study was made feasible using the spectrograph at Audi province in France. After conducting an extensive investigation, experts could discern the exoplanet's minimal influence on its 2 host stars. This manifested as a slight wobble in the orbital movements, except for their 2 suns. The Tatooine planet Kepler-16b and Skywalker's homeworld have no other similarities. The actual celestial body is not a searing, hot desert planet, but an incredible gas giant with a massive Jupiter. The discovery of the first circumbinary planet using radial velocity offers scientists optimism that they may be able to locate more similar multiple systems in the future. Future studies might look at how such planets arise despite the gravitational disturbance in their binary systems. Current ideas propose that planets develop farther away from their stars. That is all for this video. What are your thoughts over it? Don't forget to like and share this video. We will be back soon with another informative video. See you all soon.